Okay, hello guys. Today we're going to look at Codeforces problem 550b, preparing Olympiad. So first we're going to go over the problem statement, then we're going to go over the approach of solving, and then we're going to go over the code, and also we're going to over the time and space complexity of the problem of the solution. So you have end problems. You have estimated difficulty of the ith one as an integer ci. Now you want to prepare a problem set for a contest. So using Now you want to prepare a problem set for a contest using some of the problems you've made. A problem set for the contest must consist of at least two problems. You think that the total difficulty of the problems of the contest must be at least L and at most R. This is important, guys. Also, you think that the difference between difficulties of the easiest and the hardest of the chosen problems must be at least X. This is also important. Find the number of ways to choose a problem set for the contest. Okay, this is not a hard problem, guys, so don't be scared, okay? So input. The first line contains four integers. N is n, L, R, X. The number of problems you have, the minimum and maximum value of total difficulty of the problem set, the number of problems you have, and the minimum value X, L, and maximum value of total difficulty of the problem set, which is R, and the minimum difference in difficulty between the hardest problem in the pack and the easiest one respectively. The second line contains n integers, the difficulty of each problem set. Print the number of ways to choose a suitable problem set for a contest. So guys, this is n, this is L, this is R, this is X. And we get the answer 2 because this is a subset sum problem. So we need to get the subset sums which satisfy this condition that the subset sum must be greater than or equal to 5 and less than or equal to 6, and also the difference between the largest, the maximum, and the minimum element in the subset must be at least 1. So we have two subsets which satisfy this. The first subset is 1, 2, 3, which sum is 6, and this is greater than or equal to 5, the sum 6, and less than or equal to 6. And the difference between 3 and 1 is 2, which is the maximum and minimum elements in this subset, guys. And the other subset which satisfies this condition is 2 and 3, because 2 plus 3 is 5, and 5 is greater than or equal to 5, less than or equal to 6, and 3 minus 2 is 1, and 1 is greater than or equal to 1. And that's how we get the answer 2, guys. This is basically just a counter which we're going to have. So let's go over this more visually. So we have the values here, N, L, R, and X, and we have the problems 1, 2, 3. So what we do, guys, to get these subset sums is we're going to use the binary representation of integers, basically. So and basically to get all subsets of a set, we need 2 to the power n, where n is the amount of elements in the subset, guys. So we have here we have 3 elements in the subset, n is 3, so this is going to be 2 to the power n, so 2 to the power 3, which is 8, and we're going to use the first 8 binary numbers from 0 to 7, guys, and we get the sums like this. So basically, if we have a 1 in this position, we're going to get the corresponding index from the array of problems, and we are going to add it to the sum. So here the sum is going 3. Here the total sum of the difficulties of the problems is 3 here. Here the total sum of the difficulties of problems is 2. Here the total sum is 5. And guys, we have only 2 cases where the conditions are satisfied, where the total sum, the difficulties sum of the problems is both greater than or equal to 5, less than or equal to 6, and the difference between the largest, the more difficult and easiest problem is 1. One of these is this case here, guys, because 2 plus 3, we have 2, 1 and 1 here, so this is going to be 2 plus 3, the subset sum here, this is 5. And then this is greater than or equal to 5, less than or equal to 6, guys. And then we're going to have 3 minus 2, which is 1. And guys, this is greater than or equal to 1, okay? So this satisfies. No other satisfies this condition, because here the sum is going to be 1. And 1 minus 1 is 0. 1 is not greater than or equal to 5 or less than or equal to 6. And 1 minus 1 is 0, guys. So that is not greater than or equal to 1. Here the sum is going to be 4. And yes, even though 3 minus 1 is 2, which is greater than or equal to 1, 1 plus 3 is 4. And 4 is not greater than or equal to 5 or less than or equal to 6, guys. So I hope you understood that, guys. This is not a very hard problem, okay? Okay, guys, and the last case is where we get another good case, we can say, because this is a valid case. 1 plus 2 plus 3 is 6, which is greater than or equal to 5 and less than or equal to 6, and 3 minus 1 is 2, which is greater than or equal to 1, guys. Okay, so let's look at the code now. Okay, guys, I'm going to drink some water because this is my second time recording this. Okay, guys, let's look at the code. First, we have our input. We take in our four variables. Then we take in the problems in input as a vector. Then, guys, this is the cap, we can say, for our subsets, the amount of subsets we have, guys. If you don't know about shifting, we have one, and basically in this case we're going to left shift it by 3, since n is 3 in this case, and this is going to become 1 0 0 0, which is equal in binary, which is 8 in decimal. Okay, binary, and then this loop is going to run from 0 till 7. Okay, guys, this loop is going to run from 0 till 7, guys. Okay, and this is our answer, where we're going to increment the count of the answers, guys. Okay, all right, so next we have the vector chosen, which is where we're going to store the problem sets which we have chosen. Okay, guys, then we have k, which is we're going to use here in to determine which problem to pick based on the binary value of the number, the binary representation of the number. And then we have end, which this is just an iterator, which we're going to use to iterate through the problems array and add the value to total difficulty. So if we have the iteration where I is 1 here, and the k is going to be also 1 since k is equal to I, then we're going to choose this 3 right here, we're going to add it to the total difficulty, and we're going to add this 3 also to the chosen array, which stores our chosen problems for that particular subset sum. So here we have a little bit more explained detail. So when k is 0, basically nothing happens, guys, because 3 zeros will get 0. We don't add anything to the subsets, to the sum. We don't add anything to the chosen array. Nothing happens. But when I is 1 and k is 1, then k is going to be 1, right? And k in binary is going to be 2. It's going to be 0 0 1. And end is going to be 2, since it's end starts from n minus 1, and n in this case is 3, and 3 minus 1 is 2. So the array which we have is this 0 1 2. We have 1 2 3, and we're basically going to choose this 2 here, guys, because if we have k and 1, this is going to give us, if k and 1, if the last digit of the binary representation is 1, this is going to be 1. This is going to return 1 in here, like a true value. And if the last digit is 0, guys, so for example, guys, 0 0 0 and 1 equals 1, and 0 0 0 and 1 equals 0, right, guys? Because 1 and 1 is 1, and 0 and 1 is 0, guys. That's why. Okay, and then we're going to execute these two lines. All right, so yes, we use right shift, and also we use right shift to get the next digit. So first it's going to be 0 0 1, then when we right shift it's going to be 0 0, because we have right shifted to the right by 1, guys. Okay, so yeah, we have I have even written it here. We have k before shift is 0 0 1, and then we right shift by 1 and get 0 0, and k after shift is 0 0, guys. Okay, and this is one of the correct cases. So k is equal to 0 1 1. So this is the case we discussed here, right here, man. So okay, man. So when k is 0 0 1, the total difficulty is plus equal problems of 0, which is 3, problems of 2, which is 3, because n is going to be equal to 2, guys. And we're going to go in here, it's going to be total difficulty plus equals problems of 2. And as we can see here, problems of 2 is 3. So this is going to be plus equal 3, and the total difficulty is going to be 3 for now. Okay, guys, of this subset sum. Okay, and then we'll right shift by 1, so then we have 0, 1. Okay, guys, then we decrement end, so we can go back and do the next problem from starting backwards, guys. Okay, and then end is equal to 1, and the total difficulty is plus equal problems of 1, which is 2, right here, guys. And of course we push back the problems in the chosen array as well. Okay, guys, so now total difficulty is 5, and this satisfies both constraints, because 5 is greater than equal to 5 and less than equal to 6. Oh, and also 3 minus 2 is greater than equal to 1, guys. So this satisfies both of these constraints, and then we're going to increment the ends. And also we have the last case here that satisfies these constraints as well, is this one, because we have 1 plus 2 plus 3, which is 6, greater than equal to 5. This is equal to 6, and 3 minus 1 is 2, which is greater than equal to 1, guys. Okay, so that is basically what the code is. Pretty simple, nothing too difficult. I hope you guys understood. If not, you can ask questions in the comments, guys. So the time complexity of this solution is 2 to the power n times n, guys. As we said, it's 2 to the power n because of the outer loop we have. Because to generate all subsets of a set, we do 2 to the power n, or 1 left shift by n, because 1 left shift by n is the same as saying 1 left shift by 2 to the power n, guys. So this is the same thing. Alright, it's actually not 1 shift, it's 1 times. It's 1 times left shift. No. 1 left shift n is the same as saying 1 times 2 to the power n, guys. Okay, and this is the outer loop, 2 to the power n, and the inner loop is k, which k is this. Okay, guys, k is the number, k is I, basically. K is the number I. So in the first loop, k is going to be 0, second loop, k is going to be 1, third loop, k is going to be 2, 3, 4, and so on till 7 inclusive. And the space complexity is n because we are creating these arrays which are of size n. So n problems, and then n chosen problems. Okay, guys, so that's the time and space complexity of this solution, guys. Now let's go through the test cases, guys, so I can show you that this actually works, and I'm not bamboozling you, and I'm even going to submit the problem on Codeforces afterwards for you guys. Okay, so this is the first test case, this is second test case, and guys, this is the third test case. I was going to say final test case. It's not really the final test case, it's the final one they have given us here, guys. Okay, so that's basically that for this. Now we're going to copy all this, and we're going to my Codeforces user is Alexander Kremenov. You can add me as friend if you want, or whatever. We're going to do this, paste here, and we're going to submit. Okay, it's running. Let's see, guys, and you can see, guys, it is accepted 9:43. It is 9:43 right now on the 25th December. And guys, that was it for the video. I hope you enjoyed and learned something useful. Guys, please leave a comment, like the video, and subscribe to the channel. And Merry Christmas, Happy Holidays, and goodbye, guys. Have a good day.